Hello, welcome to the organic chemistry lab. Today we are going to study the synthesis of stilbene dibromide from Stilbene. As an introduction, here you can see the whole pathway of the synthesis, which you can look into more detail in the chapter 28 of your book. This is the whole scheme of the synthesis of today experiment. So, in general terms, the preparation of a stilbene dibromide is commonly done with a liquid bromide, which is a very toxic reagent since it's liquid and may be also fatally phenylate. So it has severe burns, and that's why it is not a good recommendation to use it in a regular synthesis. It means in an academic lab such as ours. That's why it is better to use pyridinium hydrobromide prebromide, which in addition of a bromine across the double bond, it is usually achieved using the molecular bromine. So, since liquid bromine is very volatile and dangerous, it's safer to use this reagent since it is still very dangerous, but it's a solid, it is not volatile, so you can more easily handle it and control and in order to prevent any type of intoxication or toxicity consequence. So the mechanism, the equilibrium of pyridinium hydrobromide prebromide is as follows. As you can see here, it is in equilibrium with a tribromide and the bromine, the salt of bromine itself. So the reactive, as you can see here, the reactive bromine is in situ available by the equilibrium of in this reagent, right? So the mechanism of the synthesis of stilbene bromide is as follows. As you can see here, the double bond attack the bromine in the bromine molecule and create a bromine cation, as you can see here, bromonium cation. As you can see over here, and you also have gas product bromine anion. This bromonium anion reorganizes itself to create this substitute bromine in the as a product of as a substitute of the double bond in the stilbene dibromide, right? So as you can see here, if we look at the stoichiometry of the reaction, we can see the bromonium ion makes only allows only the possibility for the anion or the nucleophilic to attack in the opposite direction, since it is perpendicular to the plane that creates the molecule. As you can see here better, since you have the bromonium ion here, the only possibility for the nucleophilic to attack the other electrophilic carbon, that either this one or this one, is in the opposite side of the molecular plane, as you can see here, because it is stoichiometrically blocked by the bromonium ion. So you always are going to get the trans the trans adduct or the trans conformation in the molecule, right? The trans isomer. I'm sorry, I forgot the word for a second. So the trans isomer in this type of reaction, because this is NSN2 nucleophilic substitution number 2. So it is only allows you to get in a much almost 100% only one conformation of the disubstitute product. So in this case, you can obtain 3 stereoisomers from this reaction because you have mixtures of 2 Stilbene isomers, right? And the bromines add from opposite sides. Since you have Z Stilbene and E Stilbene, you can have this isomer over here coming from this Z Stilbene and the meso-Stilbene over here, right? As you can see here, all because of the stereochemistry of the reaction. Remember this mechanism over here, in which the bromine only can attack in the opposite position of the molecular plane, so allowing to these two bromines always to be in trans from each other, right? As you can see, this is the case of here, the same case of here, and the same case of here, right? Okay, the experimental procedure now. First, we are gonna need 40 milliliters of acetic acid, 2 grams of Stilbene, 4 grams of pyridinium hydrobromine prebromine, heat on a hot plate, cool the reaction in a nice bath to form the crystals, collect products by vacuum filtration. On a filter paper in Bunchland funnel, maintain the vacuum, and also you need to wash the crystals with the minimum volume of ice-cold water. Remember that ice-cold water is 1:1 water methanol solution. If the solution is too warm, some of your product will be dissolved and will be lost. If you wash with too much ice-cold mixture solution, some of your product will dissolve as well. Then you need to calculate the yield and report to the TA. Then your TA can elect you to investigate your product by TLC. The TLC, remember, is a chromatographic technique in which you can compare the starting material with the product by dropping one with a capillary tube. In the TLC, you draw a starting point and an end point, and then you drop both the starting material and the product. Then you use hexanes in the chamber as the mobile phase, as the liquid used for the TLC, and at the end you compare the spots that you got from the starting material and the product. If you got the same relative height in both the starting material and product, it means that you have the same product. The starting material, it means that it didn't move. Yeah, I remember that you use the starting material as a reference to compare. If you have both starting material and product spot, two different spots, it means that you have that the reaction was not 100% complete. And if you have more spot, it may be that that since you got more than more than one isomer, stereoisomer in the in the reaction. The Each of them may have hues different in polarity, or as a consequence, they will run more or less depending on the isomer, and then you will be able to differentiate in all of these spots in the TLC. It is a very interesting experiment for you to actually see what was your product. Even in organic chemistry, you must know that all the reaction must be followed by TLC. It's the less expensive and the most easier way to identify the endpoint of your reaction and if your reaction was going well or not, right? Also, you can do measurements in organic chemistry of the melting point, right? In this case, we don't need to make a melting point characterization to determine if we got the product, but by it because it's too high, right? Then you don't need to attend recrystallization either, since you are likely starting with a mixture E and Z. You expect a mixture as well, up to three Stilbene dibromides, right? All three isomers can be converted to diphenyl acetylene in the next step of the reaction. So remember the hazard in this experiment. First, pyridinium hydrobromine prebromine is extremely hazardous. It can cause chemical burns and respiratory and nasal irritation. The glacial acetic acid is extremely hazardous. You need to handle it in the hood always. It can cause serious chemical burn and respiratory and nasal irritation. And the methanol is the wood alcohol. Remember that it's very toxic, and ingestion can cause blindness, can damage your neurological system as well, and you should avoid skin contact while using it. Yeah, the content of this reaction, since are dangerous, since the flask has to be heated, it means that if held by hand, you can develop either thermal bonds, or you can be the product can be in contact with your skin if you do not handle it properly. So the best thing to do to handle the glassware is by attach it to a 2-pluton clamp firmly and hold the flask from the clamp, right? You can hold it from here if you need to move it, right? You need to tie it as best as possible in order to make sure that your glass wool is fit properly there. Okay, in this case you need to obtain an IR spectrum and a proton NMR spectrum in order to characterize your product. You need to use the minimal sample possible, as it might not be possible to recover for the IR. And in the case of the NMR, you can recover your sample by pouring the solution onto a wash glass and allowing chloroform, deuterium chloroform, to evaporate, since it's a volatile solvent. Of course, you need to save your product for the next reaction step, and that's it. Oh, this is a very interesting reaction, and you're gonna use many different characterization techniques, which you must know already from the organic chemistry one. So in this case, make sure that you go to your book and you understand each step of the reaction, and most importantly, the mechanism of this reaction. So, as always, if you have any question or you have any doubt regarding this experiment, please let me know, and I can help you through my email, and we can either arrange a meeting if needed. See you next week. Bye bye.